think we are good. Let me just turn off audio here. How about Facebook? Does that work? Yes, it does work. All right, and just checking YouTube as well. To be sure that everything's working. Let's see, YouTube is live. All right, well, let's notify. Here, we're gonna need a link for that. YouTube link and which link. There we go. I guess everything is live now then. Sorry, just getting everything set up properly. I tried to stream last week, working on SynthVR, just sort of hanging out with the people on the Discord community and working out some new features and stuff like this. I think it's pretty cozy, and I hope you'll join me and hang out, do a bit of work. I think what I'm going to start out with is actually from last stream. We did some changes to collider sizes in SynthVR such that like it would be easier to grab something. But I actually learned from Chaos Basti. Hello, Sir Fancy. Welcome on the chat. I think Chaos Basti, a German guy on the Discord server, he showed me a video where he now the sort of colliders are too broad, so it's actually hard to grab things properly. So what we're gonna do now is we're just gonna branch out a new feature here and say fixed colliders, because we just sort of overdid that a little bit last time, and I think what it really needed was some more thorough playtesting. So maybe that's what I'll do next time before sending it live. So let's open up SynthVR Unity project. And by the way, guys, let me know if there's any problems with video or audio. Try to set up a better sounding microphone this time, so I hope that has been successful. Recording everything. By now it is starting to grow to a bit of a large project. So actually Unity compiles fast, but actually compiling it can take a bit of time now compared to just a couple of months ago. The code base is growing, so which is not a bad thing. All right, we're in. And what we did, for anyone who didn't see this last time, most of these components, for example a button, will have this sort of, in games you would call it a hitbox. Let's see, Sir Fancy says, does he have dual streaming set up? Yeah, trying it out. It's even streaming to my my personal Facebook page, which is a little scary, but thought I'd try it out. And yes, less delay. Should be on YouTube as well. I hope it's better now. And Chaos Basti, awesome, cool. Hope to see you on the stream later. But anyway, we have these components, and whenever you're you have this sort of interaction point at the end of your controller, whenever it gets into this zone, it'll sort of activate for this button. The problem is if you have several and they overlap. Let's say we had that doesn't show, but let's say we had several colliders, then the way the logic is made, it wants to sort of try and choose the closest object, and sometimes that's not always the one that you want to grab. So what we're gonna do is actually we're gonna go back, because the problem had mostly to do with handles on modules. So let's just go back and let's say and make this a little less lenient, but hopefully sort of give you a little more precision, especially on modules where things are very sort of tight together. So just a bit of a simple one to get us started, you know. So here's point 1. So the C axis is sort of the forward, the direction that is facing you as the player. Let's see, connectors. So these were a little problematic. Well, something happened here which is also pretty problematic. It's somehow the Y axis of this collider has been collapsed. Must have been an oversight from us. But we'll just reset it. We'll do 10 centimeters in like VR space outside. I think that's okay. Before it was 8 centimeters. We'll try with 10 and just sort of tighter boxes around the component, and hopefully that'll make it a bit better. So. And for this one, you can see it's too big, definitely. So just gonna reduce the size of that. There we go. And yeah, you can see where this would be a problem, because in the for example in the sequencer we have these very close together. Actually, we would have them like almost this close together, right? So it would be hard to grab a hold of the right one. Let's see, so we have the collider here, and we want that to just be significantly smaller. And maybe we'll make this one like asymmetrical. Just make it a pretty small collider on this axis, and maybe we'll be a bit more lenient on this side. A little bit. Alright. Here, the screen is turning off. How's that look? Still quite a lot, isn't it? To have the 10 centimeters. I think I'm gonna have to backpedal on this. Just make it all a little bit smaller. We've been knocked down way too many times, and now my tries. Deja vu round, spinning me into another lost time. Tell me where this road will end before I drive over the edge. I'm gonna make it a little tighter, so you don't accidentally grab the wrong thing. And buttons as well. And we just have the knobs left to do, and we can start doing some features. Oh. Right. Hope everyone's doing okay. So Neptune's texts on the server about the wildfires in the California and Oregon area. That's some scary stuff. I hope you guys are okay. Oh. Let's see here. Having computer problems. There we go. All right. What about the music though? Grab the next one. Yeah, we're back. We're back. No worries. 0.2 and 0.05 here. 0.03 here. And where's that collider? It's here. 0.2, 0.03. Yep, and the round one. That's already pretty tight. Great. Let's do the knob now. This is way too big right now. Just that back. Oh. 08, 4. There we go. The interactable area for one of the large dials. And 0.4, 4 centimeters, and 8 depth-wise. Okay, I think we're good. We're good on this, and we'll just replicate all this. So I think the root cause of the issue that I found here was that the handles on the modules were a little too tight, and the problem turned out to be that because they sort of grow as you approach them, so it turned out to help to actually just make them grow and appear a little bit faster. So I think we're all good, and let's see. I'm gonna see if this will run. I'm gonna use Oculus Link. So this is an Oculus Quest that we have connected to the PC. And it's always a bit interesting if it'll work. So I am enabling Link now, and soon I should have access to play SynthVR through here. Oculus is booting up. Great. So let's try and boot up SynthVR. Unity starting. And there we go. We are in. And I'm just gonna sort of get a little bit of a feel for it. So this is, let me actually just looking through the nose hole here. Maybe that's not a good look for me. I'm just gonna maximize the screen so you can see what's going on. There we go. So you can see when this connector activates, it's around here. So that's the 8 centimeters. But then, like on the sides here, it's more sensitive now, which I think is good. And I think a way that we could test that would be to summon the menu over here, and let's spawn out a rack here, and let's see, put a sequencer in there, and now we should sort of be able to control it more closely, and I think we can. I can sort of grab all these pretty quickly now. Almost. But the thing is, you want to get it just sort of lenient enough that whenever I just sort of grab for it, that I'll actually get a hold of it. Because it can be frustrating if you have very narrow colliders, you're going to feel like you want to interact and you're doing things, but you're not sort of getting control of the components. And I think this feels better. This feels better. And I don't know if you notice, but the handles are these white spheres here, they are appearing more quickly now, where they had a bit of smoothing to them earlier. So they are easier. So you can sort of, that's what you want. I want to be able to just sort of, well, yeah, I want that one. Very quickly sort of grab it. Because when I'm making music, I'm in the moment, and whenever I want to do something, I want it to be quick and easy. So it's important that you know, that interaction feel is right. So, and I think this helps. And it's okay for it to be further out in this dimension. Oh, my controller died. Because there's nothing going on like in front of the module other than these things I want to grab. So I just want it to be precise enough that I can do what I want. Which I think it is now. Wait, oh, yep, perfect. Or whatever, I want to put this to here. And I'm just all about a quick interaction right now. Yep. I'm gonna enable some steps here. Make it run fast. All good, I think. Somehow my second screen is down. Anyway, there's an error here. The update you want to instantiate is null. So that has something to do with serialization. I have an idea about what this is, and it's not related to this feature here. So let's commit our work. Commit it here, and we'll say Titans component colliders. We'll save it. This is a good song. All right, all saved, and let's finish feature.
Every notion has a counterpart.
There we go.
Yet, every idea's opposite. It's just the absence of the idea itself.
I'm gonna grab a battery while I wait.
Presence of presence. Presence is the absence of absence. Any perceived difference is in fact also a deep connection. Opposing becomes a collaborative.
All right. Feature finished.
pieces.
Let's push it. And I'll replace batteries. Meanwhile, draw this one. And that's two. Okay. So there are two things we could be working on. One is the wavetable oscillator, which is a work in progress. Maybe I can just show you here. Hello, Neptune. You made it. So for anyone who hasn't seen, we're working towards a more capable oscillator. While the one that's let's see here. So while the one that's there right now is let's just say very simple, the lab osc. It's basically a sine wave, and you can control it, and you can sort of control the notes and stuff, but it's a little bit hard. So what we have in the works here, and I'll just show a quick demo of it, is a new oscillator. Right, battle testing a new oscillator, and I'm gonna be talking over it. Let's see here. Maybe that's not quite loud enough. If you like, you can just get, instead of getting the mix, you can get any one of the individual ones. So that's what's in the works. It's a wavetable oscillator. I'm going to turn this back down. Sorry guys, just figuring it out. We can either work on that or we can work on bugs. I think are sort of the two options at this point. So guys, let me know if you have any preferences. What would be more interesting to be along for the ride? But I guess just to update you on the wavetable oscillator, the reason I'm showing a video is because it's not quite done right now, or it's not quite in a state where it's ready to play, and that is because I've replaced the sort of internal working of the oscillator. I'll show you. This is the way it's set up. So you have actually two oscillators that are running together, and each of these have like a frequency input and then fine tune. So the frequency input locks into musical notes, and then you have a fine tune. And then you can offset each of them by some amount of notes. So you can, for example, offset one oscillator by a quarter, or by whatever seven semitones or whatever you want. And then most importantly, each of these oscillators are wavetable oscillators, meaning that you can insert a custom wavetable. And some of you guys probably know this from Neptune posted this. It's a Serum. So Serum is a VST synthesizer that uses wavetables as sort of the main tone generator component. And that's sort of what we're going to be doing here. And the cool thing about using wavetables is also that we can sort of cheaply get half analog sounding music, or half analog sounding input. And the other sort of benefit of the wavetable oscillator is that you can reduce aliasing in a cheap way. So aliasing is this problem where once you have parts of your signal, once you have some frequencies that are part of your signal, some, for example, overtones of one of your oscillators, once they reach a frequency that is above the Nyquist rate, which is half your sample rate, that means they are now too fast to be captured in your audio signal. And what will happen is this sort of weird effect where it will sort of wrap over, and you'll start getting very deep sort of low notes, and it'll feel like noise or something like that. That's you call that aliasing, and generally you want to avoid it. So what you can do with the wavetable oscillator is you can actually downsample. You can use several wavetables internally, and so when you try to play a frequency that would introduce aliasing, you can actually switch to another wavetable as sort of another version of the same wave, but that has been sort of smoothed out more, so it doesn't produce as many high harmonics. So that's a pretty good trick, and I have sort of an initial implementation of that, which we can look at, I guess. Let me just open Juice here, our Producer. So the Producer is a tool for managing Juice code, and Juice is sort of the audio backend for SynthVR. So the way that most audio code in SynthVR is being run right now is as Juice audio processors, and so there's sort of two things going on at once. So you have this sort of audio library, signal processing library, that is written in C++. That gets baked down into a library that that the game engine Unity is using, and so you have this sort of back and forth between native and managed, where Unity is the managed part. So I got this great wavetable oscillator implementation from Nigel Redman from a blog that I was referred to called Ear Level, and it's really neat. And I don't think I could have done this myself. Obviously, a lot of work has gone into thinking this implementation. But basically what it does is you can take some sort of waveform, it'll compute the frequency components of that waveform, and then it'll generate some amount of wavetables that you would need for like an aliasing reduced oscillator, which is cool. And so that is part of, this is sort of the thing that, the part that I can sort of take some credit for is this processor implementation. So this is going to be available to SynthVR to run sort of inside of a module, let's say. And what this element does is it handles these wavetable oscillators internally, and it handles the flow of how data is being copied to and from these oscillators. And then it handles stuff like parameters, stuff like, well, what is the tune that I want, what is the detune, the gain, etc. You can define all these things as parameters and pass that in. I do have some ideas for how to improve this way of building the signal processing part of SynthVR, but it is dependent on some tools that don't necessarily exist yet. So where I'm at right now is actually this worked. This worked pretty well, except for the fact that I want Unity to be able to write wavetables into this processor. So there is this sort of communication which is going on between Unity and this native library, where Unity can send parameters or it can send like numbers or strings, sort of data that it wants the processor to use. But in order to do this with a wavetable, we have to send quite a lot of numbers. So even like a short wavetable, let's say, I have some examples here. So let's take this one. It's nothing, right? I'll open it up in Audacity just so you can see. This is someone called Adventure Kid, I think, who has made loads and loads of wavetables available on the worldwide internet. And here is one. And you can actually see in Audacity, you can see the individual samples. So each of these are a floating point number. The ones close to the line in the middle here will be 0, and then 1 at the top, and then 0, -1 at the bottom. And what we want to do is we want to send this like long string of numbers. Essentially, this is 600 floating point numbers that we want to send to the processor, such that it can start playing this back. And if you're curious how it sounds, let's see if we can play it looped. That didn't go to the right place. That's how it sounds, at least at this playback rate. And then obviously it can be tuned for whatever. So the problem I was running into was, I thought, wouldn't it be cool if you could save these wavetables in your patch file? And so what I did initially was I implemented it such that the autosave, and let me just open the autosave here, such that the save system, which is where we save all this information about the patch you're making. Let's go to the top. You can see, for example, here's the version of SynthVR. There's like a long list of modules, where they're placed, how they rotated. Do they have internally some parameters? You know, this is the wavetable, how it's sort of saved. Well, it's got a tune parameter, and this is what I set it to, etc. And then I thought, wouldn't it be neat if we could just save the wavetable? You could save that along with your with your save file. And what resulted was a field called I call it float array data, and it's just absolutely full of data. And this is getting JSON serialized, which is a certain way of sort of serializing data. And it ends up just taking so much space. And when you're transferring this information between C++ native code and managed C# Unity code, you run into a bunch of problems. So I can't do this, basically. Let me start up the music again, no? I can't do this. I can't save it with the file. So we have to think about what we can do instead. And what I'm thinking is I'm gonna go and in the wavetable oscillator I'm gonna implement a parameter, like an integer, like a number, that'll sort of define, well, what's the index of the wave that I want. And then in the Unity project I will implement sort of, for example, 10 different waveforms that you can choose between. It would have been cool that you could share with each other if you sort of loaded in a special wave for your oscillator. You could share that with someone else. But what you'd have to do instead now would be you could maybe replace them, so the waves would be inside of the Unity project, and you could sort of replace them after the fact. Unity would load them instead. So I think that's what I'm gonna attempt to do. Let's see how that goes. So this is standard Juice API stuff. I'm gonna close down Unity and let's make a couple of integer parameters for controlling the wave of each of these ones. So let's say oscillator A wave, an integer parameter, and oscillator B wave, also an integer. Music a little loud. Alright. Thanks, Sir Fancy. Also a loud track. There we go. Hope that's better. Makes the stream a lot more epic. Yeah, it's true. So I was looking into, I got hit with copyright stuff on YouTube, and so I was looking into what music can I use. And don't get me wrong, I like Monster Cat, but Monster Cat has a license where you can actually use it in the stream and not get copyright struck. So so I thought that, you know what, that's good, but it's very sort of it's dubstep, it's drum and bass, and I like that. But, you know, it's alright. It's alright. Oops. I did like having more sort of indie electronica stuff on last stream, but that's how it is. So in C++, you have typically you have header files and then I guess implementation files. In the header files, you sort of define all your variables and your functions, and then you actually implement them in the other file. Extreme coding, isn't that right? Yeah. Hacker man. Anyway, let's get this parameter implemented. So we're gonna instantiate it here in the constructor for the wavetable visual processor. And it's gonna be an audio parameter int, and we're gonna call it oscillator A wave. And we're gonna provide a description. Sets the wave of the first oscillator. And now we get to choose what is the minimum value. Well, the minimum index that you can choose will be 0. And then we get to choose how many waves should be available in the wavetable of oscillator. I don't know, guys, what do you think? How many? So you need sine, triangle, square, sawtooth. That's like your essentials, your basics. But maybe then maybe you want some special waves as well. You just want a bit of choice, don't you? I'm leaning towards like 10 different ones. I don't want it to be too many that you sort of get stuck and there'll be just like there's 500 wavetables to choose from. You know. You can always fill in the gaps with wave shapers. That's right. I mean, you're going to be doing a lot of mangling afterwards anyway. So you want to have the tools. In VCV Rack, it's you just have the 4: sine, triangle, square, and sawtooth. I think it would be fun to have some special waves, especially like complex waves. If you've ever used Massive, the VST plugin, they have a lot of complex waves where you can get more sort of metallic sounding things. So might want to go above. Modern talking, yeah. That's one of the wavetables you can choose. I remember dubstep, which is sort of emerging. Oi, 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 oi. That's how it sounds. When dubstep was emerging, this would be like the way. If you want to make dubstep, you just gotta use modern talking. And I remember Knife Party, which is sort of a spin out of Pendulum. At the time, they released an EP, and it was called 100% No Modern Talking. I think it was a bit of a massive pun. No modern talking, yeah, that's right. Anyway, we'll be sure to have a modern talking option in here, so you can really spice it up. Modern talking, yeah, I used it a lot too. I ended up finding out that like for a lot of the dubstep stuff, it was nice to do like a bunch of like multi-band stuff. So you'd have relatively simple sounds, then you'd like supplement a sub oscillator to really do the bass part, and then you do like multi-band distortion or something like that on the rest of it. And that will really sort of crank it up. Kind of blocks my bands, yeah. Let's do. I think 10. I think 10 options is a good. It's a good number. And 10 options. Also with modulation. For warmth, I mean, we could integrate sort of a wave shaping thing in the oscillator itself, but it all comes with a DSP cost. So the more stuff we put in the individual module, the less modules you're gonna be able to have, because you're gonna do more stuff. But then again, I mean, that's what most hero work has come to now anyway, that you have these sort of very complex modules that do a lot, and then you just have not that many of them. Let's think about it. Maybe a wave shaping thing, yeah, might be nice. Alright. Let's do 8 for now. 8 waves, let's keep it simple. So, all good. And actually, this parameter will just be a sort of proxy for Unity to know what wave was selected, and then it can send the wavetable data to this processor, so it knows to send it here. And I think that is all we need. I'm gonna revert some changes to all of the audio processors come from this base class, the audio processor and the base processor. And what I did was I tried to save this float array data, but I see now that it's not gonna fly. It's gonna be too much data to store in a save file, especially a JSON encoded save file. So let's just open these up and make it such that the float data isn't saved, but instead we will save these parameters that will tell us what is the wave that we want, what wave number, and then Unity will sort of inject that data into the processor. So this is where the state of the processor is being saved to JSON. Save the parameters, we save the name of the thing, etc. to be used later. Okay. So I think we're ready to compile that. Yeah. Working. This is where we will be told there's something wrong with the code that we just wrote. Open up the Unity Hub meanwhile. Oh, there's a new version. Let's see here. What's next? Cloud None. Makes some pretty good garage tunes. Come on. Can take a long time sometimes. There we go. And it says it's unable to start the program. Well, that's because it's a dynamic library, so it's not supposed to be able to start. But it's sort of, this library provides the signal processing code, as I said, through a sort of this sort of API where Unity can use these functions to interact with native signal processing stuff. That's how we're doing it right now. Something that I'm interested in and started to look into is, if anyone's heard about it, is Faust. So Faust is like a domain-specific language for audio programming. And what you can actually do with Faust is you can compile it to C++ code. So you can write some cool, like get started pretty quickly, write some cool signal processing code, and then bake it to native, so to run really fast, which is important because this application has a lot of work to do. It might be simple on the graphical level, but on the CPU side, it's got a lot of work to do because of all this signal processing. Anyway, so let's have a look now at the wavetable VCO module. It's very ugly right now, as you can see, and I can also see the colliders haven't been updated. That's because we need to merge in Philip. Merge conflicts. What's the conflict? Oh, this doesn't matter. All right. This should update now. Or did it not merge in properly? Merge. Okay, try and merge it. We have a bunch of unlabeled buttons here. We have the coarse pitch, then we have like fine tune, we have detune between the two oscillators. We'll have offset on both of them. It should be updated now, but I feel like not. Oh, I think I discarded my whole merge. Git. Resolve using. Fine. Now. I believe. Alright, that looks a little more reasonable. So now we have the latest changes. Okay, so what we need to do now is we need to have Unity pass in these waves based on a parameter state inside of the audio processor. This is a little hairy, so I hope I can figure this one out. What we have here at the top level is the the module that contains the all of the processing logic and all this stuff. They have they define where all their connectors, how you can connect with it, and then they define this stuff, how you can interact with it and how you can change parameters. So I think I'm gonna have to fit it into this interaction API somehow. So I do have some code here that will take that'll take this module and it'll set the waves. So I think we'll need to do something like that. So the way we did it before was by updating the processor state, which we can't do anymore because it's no longer, the float data is no longer part of the processor state. So what we need is a way to set. So we had this function, we had this set float array data. So we need a way to set that. And that'll be in here. So this is how you do native. It's called interrupt. So working between C# and C++. That's working between managed and native, managed and unmanaged. So we're declaring here's something in a DLL that we want. It's called set flow array data, and we'll take a pointer to a processor. It's not so normal to deal with pointers in C# code. Welcome back, Neptune. No worries. We're just hanging out, writing some code, doing some native stuff right now for the new oscillator. So, what we also need is to provide a pointer to a float array. Issue here. We need to mark this as unsafe. It's because we're using actual pointers in here. This code is no longer safe. It's very dangerous. And you have to be careful because when you're doing native stuff, you're shifting around memory, and if you access it incorrectly, then everything crashes. So. But this should be okay. It takes an array of floats. Is that right? This other one took channel pointer. Yeah, this should be good. So now we have connected this C# code to some native code, and we want to also make that available in here. So we want to say set float array data, and you can provide a list of float. We'll call that array data. We'll call it data. And what this will do is it will use native processor wrapper. This is the connection to native code. Set float array data, and it'll refer to the processor it's managing, and then it'll refer to data to array. Now convert the list to an array. I think we can just do it that way. And we need to tell it how much data is there. I'm going to give the count. And you also want to be able to set the index. So this is basically such that Unity can say, oh, for this oscillator, I want to, like, in slot 1, I want to put this wave, and in slot 2, I want to put this wave. And then the processor can internally figure out how to to use that data. It just knows now, oh, some float array data has been sent to me, and I can use that, for example, to play back special waves. So I have a float array that I need to convert to a pointer, and how is it that I do that again? I'm trying to remember. Let's Stack Overflow it. Float array to pointer. I think you can literally just get the pointer, can't you? Need to pin / fix the arrays in memory. Okay. Right, that's the thing. So, because in C#, our memory is managed for us. So we need to say, well, in order to do this safely, we need to pin the data down in memory. Is that allowed? Public unsafe. There we go. So now we've pinned the data down, and we're going to provide now a pointer to the data. So we can set it. Great. And that is. This is no longer part of processor state. We're no longer saving the float array data. That is Unity's job now. So it's a cool song to Tokyo Machine. Okay, so processor API can now say you can basically set float array data, and you need to provide a list of float data, and you need to know where you want to put it. And in the case of basic like processor implementation, this doesn't do anything. Maybe it should warn you, say this is only relevant when we are dealing with native processors. So if we have a processor that's running on the C# side or some other sort of implementation, then this won't be necessary, but we want to make this available. So debug.log, and what we want to do is we're trying to set float array data for. Oh, you know what? You know what we're gonna do instead? Instead of logs, we're just gonna throw a not implemented exception. Hey, this thing is not implemented. Don't bother it. Okay? And we'll go back to the native processor. And what we'll do now is we'll do public override unsafe void set float array data. Great. So now you can set float array data on a native processor. So far, so good. Okay, let's do it in here. Sorry, this is more it's a little more technical and implementation specific than I thought. But let me know if you're still alright. Okay. Now we have a way of setting data in a processor. Good. So let's zoom back out. Deal with errors. This is demo float array setter. So this is the little demo component that I wrote that can set the wave of the thing. So it says this doesn't exist anymore, and that makes sense because it doesn't. So what we want to do instead is we want to now use, if we have a module, we want to do module to set, that's just what it's called here. Set, we want to get its processor first of all. Module does more than just manage a processor. Set flow array data, yes, and we want to do, say, wave A data. And we want to set that for index 0. And this is not allowed because this does not accept arrays. That's okay. Feels a little weird to convert it to a list, to make it a list and convert it to a list and then back to an array. So let's just actually make it an array here. Go. We no longer need to convert it to an array. Now, let's go. Yep. Alright, so now this component should technically be allowed to set these two arrays. So let's see if it works, I guess. We might get errors, that's okay. Deal with that. Alright. So something happened because it is making a sound. So that's a good start. But now Unity crashed. And I figure it's got to do with this autosave. So I'm just gonna kill Unity. Whoop. This is dealing with native code is sometimes annoying. So let's try and boot up Unity again. And we can choose a wave to set. So let's go, I think I have them downloaded here. Adventure Kit, extract all. Yeah, sure. Oh, it's a lot of data here. So, Unity. And resources, audio wavetables. See, we have these two available right now. Let's try and put in a couple of these, see what they're like. Can't hurt. This is an analog-like square wave. It's not a perfect square wave. Same goes for this. Some imperfect sine waves. All of this can be part of giving a little more character to the oscillator, making it feel a little more analog. So, you know what, let's just say that, let's put a square wave into one and a sawtooth in the other. Call it a day. So let's do that. Let's lock this in. And of course I forgot which is which. Okay. 2 and 3. Those are the ones. Alright, so 2 should be a square wave and 3 should be a sawtooth. And this should wait 5 seconds and then set that data for these two waves. And technically that should be enough. So let's see if it works. I'm a little nervous about Unity crashing here, so there might be like some memory leakage or something going on. But anyway, actually kind of need to not maximize this. So try to make it so you guys can see. There we go. But I need to see the debug log. So here we are, SynthVR project, and let me just, because this is not on the menu yet, so we just need to go to modules and wavetable VCO module, and it should appear. Move it around. All right. There we go. So you can sort of grab this from here. Good. A lot of wires hanging around. Summon that menu. Okay, so we have a speaker here. And if this worked, which it very well might have not done, I would expect a square wave to come out of this. And nothing came out. So that's an issue. What about this? Nope. Nope. Nothing to see here. It did not work. Okay. Okay. A lot of switching around here. So what happened here? Did we not manage to call the code? Is that the problem? Or now we would expect the autosave to at least have saved the setup that I just made, so I can like restart it up. I'm just going to check my save data and autosave, and we can see the autosave is now again, it is lean again. It is 2 kilobytes instead of 40. There's a problem. There's a problem when destroying the module. So this is good to know. What could be the issue? Is it this data that's not correctly sort of released or something? I'm gonna have to hard exit again. Looks like a memory leak. No, well, the memory is not going up, so we're all right. Let's have a look. Wavetable processor and wavetable should be recomputed, and that's all good. Let's put this music back on while inspecting. Whenever we destroy it, might be this this data that we're not managing properly. The base processor. Where is this float array data? Oh, it's here. It should technically be okay. Okay, let's... I have an idea what's the issue here. Might be this. So when you're passing text data back and forth between Unity and native, you have to sort of cap it somewhere. So you are allocating some memory, and then you're putting some text in there, and you have to let the engine know how much memory you're intending to use. I'm thinking that this might be related to that, because I did greatly increase the possible length of this, or the amount of memory that was allocated for it. So let's see. We're gonna do some debugging now. It's always extremely fun. So let's see. We actually need a debug build of this. So let's just do that first. We'll build the debug. And while we wait for that, let's put some breakpoints. So I want to know when some float array data is being set. I care about that. I also care about when we are handing state back and forth between the processor and Unity. Let's see what we can get from that. I think it's a good place to start. Let's do the same on the native side. We want to see when state is being gotten or state is being set, and hopefully that way we can figure out where this is failing. So let's open up Unity. Should be faster this time. Cheers, Chaos Basti. I'm gonna give you a beer emoji. Alright. Are we all good? I think we are. So to debug, let's attach to process. We're gonna attach this debugger to Unity. We're gonna go crazy because we're also gonna attach the managed debugger to Unity. So we're just gonna be all debugging all over the place. Alright, so yeah, let's boot it up. This is Haywire as well playing. It's good. Cool. So SynthVR started, and we are going to get the state of this processor, and looks like we succeeded in doing that, and we can have a look. What's the state like? Well, it's a wavetable VCO processor, blah blah blah. It's got all these parameters. And all this looks fine. Yeah, perfect. So that's all good. Let's continue. I don't feel like we're succeeding in getting... Oh. Alright, so now we have some state to set. And that is because we have loaded the autosave and we want to update all these parameters. Good. Of course, tune, fine tune, etc. So that should also work fine. We converted the state to a JSON string. Yep, it's all good. And we set the state. And on the managed side, on the native side, we do receive this, and we look at it, and this looks like a valid JSON string. You can even JSON visualize it. Yep, it looks good. So we're assuming that's fine, and we can step through the code. We set all the parameters, etc. Good. Continue. And we're all done with setting the state. Hey! I hear a sound. Oh, there we go. So now we get into set flow array data. And we got an array of 600 values. This is that wavetable that we want to set. Whoop. Something happened. Something crashed. What's the side of it? Okay, maybe it's the dual debugger thingy. Anyway, we did get some data on this end, so let's see if index is lower than float array at size. Yep. And then we get in here and we start now the thing is when I'm setting a picture like this, I wonder if the data is being copied or if it's directly referencing the data. This is that memory thing again with C++. Copy from array. I just want to make sure that this is what. I should be good. Should be good there. And then it calls on float array data updated, and that should sort of prompt the wavetable oscillator to recompute its waveforms. And it does it again. This is the second wavetable that we receive. Okay. So some data was set. Do we feel like this sounds like a do we feel like it sounds like a square wave though? Oop. I think there's a problem. Definitely a problem here. Am I still in a debugger somewhere? No? So I managed to write the float arrays and then something happened. That is annoying. This is part of the reason why I would love to get Faust working potentially, because I do know how to write C++ code, but it's not my main thing, and I do make a lot of mistakes around memory and stuff. So I have a lot of this issue here where I'm sort of trying to figure out what it is that I'm doing that is causing a crash. Luckily, I think main SynthVR is pretty stable, but yeah, sort of depends on the day, I think. I'm gonna log into my computer here. An issue. Let's reboot it. Okay, so what's next for us? So I feel like we narrowed it down that the data was actually set, but somehow something went wrong afterwards. I'm just gonna try and ask to recompute. I'm just gonna try and hook in where the wavetable is being computed. Because I feel like that might be the issue. Obviously it's hard to know because it's native and I don't get a log message. It just sort of crashes and that's it. So, alright, let's see. Am I all set up here? I don't know why it thinks that I should have an issue there, but and load it up. Yep, and we get to this stage, and this starts by calling it on itself, just with a sort of default thing. I don't care about this setting state information anymore. I do care about set float array data. So there we go. And now we are setting some float array data. And another one, yeah. And this won't be recomputed until the oscillator starts running. So let me try and just sort of, there we go. So the audio started processing and we made our way to recompute wavetables. So I just want to inspect what's in here now. So let's see. Base processor, and we want to do float array data. We now have correctly, we do have two 600 length float arrays. So we successfully copied that. We did successfully copy that wavetable over. So that's good to know. This makes me curious what is going on there. Alright, well, we're setting up two new oscillators. Good. And something happened. Did it crash? We're somehow still live? Or no? What's happening here? Boss. What's going on? Everything went fine until I started messing with this. Okay, I think we're gonna have to go in here to see what happened. And I'm expecting Unity to break. No. I would expect it to anyway. Booting up this second computer so I can actually see that chat. Okay. So Unity is definitely broken now. So we're back in Task Manager and kill it with fire. Go. So I think we're narrowing it down to this oscillator wavetable is somehow it's doing something bad. So let's look for it. Tune. It could be lagging because you're streaming. Yeah, although this is a different computer, so it's just a MacBook. I don't know. I think it just sort of crapped out or something. Cool, you're still here though. And I see Neptune just sent me a nice list of music that is stream friendly. Cool. Well, check that out. Check it out and maybe include it next time. So we can listen to not only EDM, but we can also listen to cool electronica or indie music. Monster Cat, I guess, is technically still indie music, but you know. Okay. So we're gonna soldier on. This is a little bit of a frustrating problem, but hopefully we'll get it sorted. So this is not a problem until the second time it happens. I don't care about this because it's a short wavetable. Making a sound, and 5 seconds passed, and we're trying to now pass in this new thingy. Float array. Okay. So, where am I? I'm over here. So the float array is being updated. Well, that's good. And it's being updated again. That's also good. And now we're trying to recompute that wavetable. So where does that fail? Because we have, let's see here. We are now getting ready to loop through this wavetable and do something with it. Okay. We only have this that's failing. No. So it should be. So we should be able to get through this safely. Press continue, and we do. We encountered some non-zero samples. That's fine. Now we want to FFT that. Whoop! Broke in, but we're a little closer than we were. We know there's an FFT screwing. The weird thing is that it sort of keeps going, but then it crashes when I try to close it. At this point, I should just keep the task manager open. Oh. That was bad. We're reopening Unity. And how are we doing on streams? We're live. This is good news. There's people watching from Twitch, I see. You guys prefer Twitch over YouTube? It's past Twitch, yes. Yes. I like Twitch too. I just figured since putting up the trailer and stuff on YouTube, it made sense to sort of to run the stream there, since there's some subscribers there already. I think for streaming I also prefer the Twitch platform. Okay, so we know there's something wrong with this FFT. For anyone new to this is a fast Fourier transform. So this is a way to take time domain signal, for example a wave, and figure out what is the sort of frequency content of the wave. So that is what is being done here, and something is breaking. And as you can see, this is a very nice, easily readable code. And if there's something wrong, it's definitely not going to be an issue to figure out what could potentially be wrong with it. So problem. But originally adapted from Fortran. I appreciate the work that's gone into this. It's really nice. So we are attached to Unity. Let's try to run. Okay, so this is the initial wavetables that we're calculating, and I'm sure we're doing that a lot of times. Okay. We got our basic wave going, and then we get hit with our wavetable. There it is, 600 values. I do think it might be related to this. I feel like we should be copying this over directly. Let's see. Okay. So we get the float array data, and now we get into the FFT. Okay, so let's step through. If we can hear a little snippet of audio for every time we're stepping through. Well, it seems to be working. Try to step through this loop or continue through this loop. Oh, okay. So, well, make sure we have a power of 2. Oh no, this is the issue. Okay. Okay. So, we're passing in a 600 sample wavetable. And this Fourier transform only works on power of 2 length signals. So it needed to be either 512 or 256, 128, etc. So this is good to know. This is good to know. I feel like this has been commented out, I suppose, because he knew, Adam made it, knew that this was the case. So we need to check if it's a power of 2. And who should be doing that checking? Who should be doing that? I assume. Can I do asserts in C++? I want to assert that it's a power of 2. And if it's not, then I want it to break, and I want to know that some non-power of 2 thing was passed in. So let's see, C++ assert power of 2. Stack Overflow for the rescue, to the rescue. So this is pretty close to what this guy has written. Wouldn't be surprised if it was taken from Stack Overflow. This is from 16 and this is from 14. Okay, so we want the newest answer, I figured. How are we gonna do this? I think let's put it here for now. Is power of 2 if so we're wanting to check if this is not a power of 2. Put the negation in the wrong place there. N must be a power of 2. And if it's not, what can we do? Can we throw C++ throw exception? Must be some standard library to that for that. Let's see here. Throw exception with a variable. Okay. Blah blah blah. Just looking for a. Okay. So throw. What? Standard. What? I don't have that. Throw standard runtime error. Oh, I need to include a module. So let's include standard accept. Go back down here and we'll say standard runtime error. What can we pass? We can pass a string, right? There we go. Time domain signal must be a power of 2. Exclamation mark. Okay, let's kill Unity again. That's a bit of a relief. I think this would be the issue. Yes, yes, eggplant Rick. 23 bugs, fix 1, 107 bugs. Fortunately, this is the case sometimes. Quick maths, even. Yeah. Mo code, mo problems. At least we can try to be neat. Quick maths. What I really want to do is clean this up as well. It hasn't really been written in a way that's consistent with the rest of the code base. But then again, the native part is still subject to change. So, okay, we know it's gonna make a fuss now. I think if I actually try and run it now, it should at least fail. So let's attach this to Unity, and this is very much a day in the life of a programmer, you guys. I know we have some other programmers in the chat, but some days you're developing new stuff and it's really working out, and other days you're just debugging and it turns out to be that you put like an exclamation mark in the wrong place or whatever, something. It's always something like that. Okay, code runs. N, is N a power of 2? Yes it is. Very good. Is 8 a power of 2 again? Yes. Yes, yes, yes. Good. 8 is still a power of 2. Good. SynthVR runs. And now, 600. Is that a power of 2? What? Is 600 a power of 2? What's going on here? Oh, I'm stepping through the wrong code. Just looking over here. There we go, 600. Is it a power of 2 or not? I want to know. It is not a power of 2. You've been a bad Unity, and you have passed me an incorrect time domain signal. Throw error. Great. Okay. So we expect Unity to break again. Break. Whoop, whoop, accidentally stopped some process. Okay. And next we have to make sure that we're not passing a product through. And this is wavetable processor specifically neutral. I have to say your code is really good. After seeing the mess that is yonder a dev, that is. I'm glad you think so. I think at least the C# side, I think I quite like how it's been structured. So pretty happy with that so far. It's more the native side, which is a little sketchy in some places. What is yonder a dev? Yonder? I don't know what it is. And I'm curious. Gotta make a Yandere simulator. Looking, I haven't heard of this. Yandere? What is that? I'm gonna have to Google it. Sorry. Yandere. Oh, it's some anime stuff. Oh, I see. Yandere simulator. Have a look. Senpai will be mine. That looked interesting. But hey, you know, I think when you're running your own project, sometimes it's a hard balance to strike, because on the one hand, you want to get stuff done, you want to build features. That's what's going to make the users happy. Is features, of course, also that it doesn't break. But equally, you want to have clean code. You want to have clean code so that when you come back and you're developing new stuff, it doesn't take too long, because you have to sort of, because you can't find your way around stuff. But then sometimes you end up overdoing it, and you sort of over-engineering it, and it becomes so clean, so generic, your code, that you don't understand what it's doing anymore. And then again, you pass that sort of threshold where you're not productive anymore, where you're not getting stuff done. So I try my best to keep it good. What do we have here? I'm gonna open this up here. Ooh, big switch statement. Yeah, I think this is typically considered a bit of a code smell to have. I mean, it's an if-else, but it's a big switch statement, isn't it? But yeah. I feel like sort of you should try and put stuff like this. You can put in you can sort of put it in a mapping. So this is all about like mapping a string. You have an eye color string, which can be white, black, red, yellow. You need to map that to a color. So one way you can do that in Unity, for example, is you can use scriptable objects. So I believe there is some code here somewhere which does something like that. Just show real quick. Trying to remember where it is. Guess I'm not that. So I ended up earlier I had more of these, but it was basically I need to map a button to switching to a certain controller. So in the old menu system, you need to map a button. When you press this button, the teleport thing should start. And instead of hard coding which button it is, which you could do, you can hard code it in. And, I ended up making this scriptable object. And what you could have also done is you could have put it in the inspector and have it be like sort of a configuration that you do ahead of time. But if you have very many of these, like this guy has like a green and black, yellow, etc., it can be easier to put it in a scriptable object. So this is sort of like a data container, and it sort of contains, well, here's like the button to map from, here's the controller to map to, and here's some other settings around when you do this toggling action. Do you want to hide the controller or do you want to stay? And so that can be one way, anyway, of reducing the amount of like avoiding big switch statements and stuff like that. But of course, there's different styles to doing that. So, we've throwing an exception now. If the wavetable is not a power of 2, I would have never expected that to be the issue. But we caught it, which is good. So let's see. Let's go to, where is it? Because it was working before, and I was like, what happened to make it start breaking? That was the problem. So right now we're just playing around in this little like demo component, so we can figure out how we want to do this properly before we implement it in a bigger component. And what we want to do is we want to ensure that the thing is a power of 2, and to do that we actually need to somehow interpolate it. And I want to look that up. On Stack Overflow. So just open Audible for a second. Audacity, sorry. The problem we are faced with is, say we have, this is our wave, and it's 600 samples long. Each of these little sticks here represents one sample and the value of that sample. We want to go from 600 to 512. But we don't want to just cut the end. So you can see if we did that, we will have now messed up the wave. It's not going to sound like you want it to. It's not ending properly. So what we need to do is we need to downsample it. Downsampling, that's what we're doing. So C# downsample array. How to do it? Array to resize? No. It's a 1D array, so we don't need any fancy image stuff. Float array resampling. Resample. Okay, here's some information about it. Is there anything I can just use? We need interpolation, yeah. But I want to just use something and not have to think about it. Resample. So someone here wrote a little script to do this exact thing. Let's see. Just gonna inspect it first. Code review. Let's see. Resample. I know that it's a graphic thing, but can you not save wavetables as some sort of vector? I don't know. I mean, you can definitely represent the wave as a vector. Yeah, that's a good question. I'm not sure. I wonder if I mean, maybe it would be a more compact representation for a simple wave. It would have less points anyway. But I'm not sure. You have an idea? What's your idea? I'm just gonna look at this while you're thinking about it. need to resample. And this looks like it's going to do the trick. Does it interpolate? Yes, this is interpolated. I don't like the naming, but I can fix that. So let's steal. It's time to steal some code and make it our own. I'm going to put this in float array. I'm going to make a script called float array extensions. And I'm going to add the capability to resample float arrays. So let's make C# script float array extensions. There we go. And I'm just going to look at how I've done this in the past. Make sure it's at least sort of consistent. So we'll put it in the namespace. The namespace is SynthVR utilities. For anyone not familiar with namespaces, they are a way to make sure if I accidentally use the same name as some other code that I'm using. For example, I'm using the name module for some of my stuff. That is also this .NET reflection library also uses module as a class name. Using namespaces, I can make sure they don't collide. That's all. Okay, so we want to say what we want to say is we want to say an extension to a float array, a valid float array. There we go. Data. And I want to target size. I want to resample this to a new length. I'm not going to call the function resample. And what I'm going to do is I'm going to grab this code here. There we go, resample. Whoop, I accidentally overdid it. This is working on double arrays, which I don't care for. We're replacing source with data here. And in is target length. Trying to change the naming so it's a bit easier for me to understand later what's going on here, so I don't have to read it again and again. Okay. And we don't want to work with doubles, we want to work with floats. Float, 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 float. There we go. And the formatting is absolutely horrendous. Let's format it. Thought I can do that like this. I'll fix it myself. Oops. There we go. So, let's rename this. So we have a target length and we also have a source length. I actually do want to call this source actually. Alright, source length is source. Okay, good. And we are allocating a destination array, which is the target length. It's not called destination. It's called target. Oh, it's called destination to keep it clear. And instead of targeting, we'll call this desired length. All right. I accidentally put something here. I don't know what it is. Okay. Looks like I am using some unnecessary stuff here. So this isn't necessary, and this isn't necessary. I think I did something wrong here. Isn't N supposed to be... N is supposed to be the target length, desired length. And M is the source length in this thing. So I times source length minus 1. Okay. Should be alright then. Just gonna put these here for good measure. Alright. JD. What's JD? JD. J and JD. What is J and what is JD? J is the source index. And JD is the interpolated. I'm not sure. I am not sure about that. Let's call this float array extensions. Here's a good one. If you're not sure what's going on, you can put it to do. What's going on here? That's something to look into later. Okay. Alright, so we're back and we have some arrays here. We want to resample them. Right? Resample. And in order to use resample, we need utilities. And now we can just call resample here, and let's because we know these are 600 length arrays, let's just resample them to 512 because it's a known quantity. We'll have to do that more cleverly later, but that's alright. Will it blend? Something's happening. Yes! Woo! It worked. Oh my god, so much work. Okay, I'm gonna put my headset on and I'm gonna try it out. And maybe we'll also kill the music. That's one squarey boy. Isn't that right? Isn't that right? And one of them should be a sawy boy. Ooh, beautiful. Square, saw, square, saw. Wow. All that work for a square and a saw. But hey, look at that. I can now mix between them. Alright. What are we doing? Okay. So, now that we have actual sound coming out, let me just play it for a little bit. So, bring, I don't know, a bit wired up here. So let me just bring a sequencer into the mix, and we'll need a clock for that also. Clock to sequencer. And we will also need a little quantizer. I'm just gonna do my best to not screw up my desk here. So we'll pass the I like to personally, holy shit, okay, there we go. gonna move a little bit back. Try not to screw anything up. So personally, I like to feed the value of the sequencer. I like to feed that through an amplifier because then I can do stuff like this, blah, 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 and I can make it represent less than 5 octaves, which is the default for the oscillator. So let's feed this through. Okay, we'll listen to the square wave. Beautiful. So we have several inputs, and one of them is pitch input now, which maps to the entire 5 octaves. Oh yeah! Okay. I kind of like that. That's nice. Sounds pretty good to me. Okay. But hey, we don't just have one oscillator, we have another oscillator. It's right here. It's a sort of a, I don't know, it's a sawtooth. We can do better, I think, with the wave that we pass in, but for now this is good. And look at what we can do. We can mix in between the waves. And we can shift one of the waves, so this one I can shift it up. Yeah, sort of quarter stack. Oh, I've got to put it back now. Okay. I can detune them. Get a bit of free warmth or whatever. Okay. That's pretty fun, but we can do more. Because we can bring in this good old little oscillator and we can feed that to the wave mix. So let's do that now. Get ready. So right now, listening to both waves at once, right? Now let's feed this to wave mix. You do fun stuff. All right. And obviously this would be even more if it was sort of more distinct waves. If I play it slower, it'll be clearer. Lots of fun to be had there. Suggestions welcome as well, by the way, if you have any ideas. Okay, just to make it sound a little bit better, let's bring an envelope into the mix. I'm trying not to screw up my stuff. I don't need info on that. I'm gonna do that. Okay, and we're gonna actually split the trigger signal. One of them is pretty fun to put in the oscillator. Oh yeah. I'm gonna keep it slow. Okay, that's the trigger, and we also want to send the trigger to our envelope. There we go. It feels a lot better with the colliders updated, actually. I really like it being a little more precise. Okay, let's bring another amplifier into play. So bring that to the amplifier. It's so nice to see a non-sine signal in here too. Even though this oscilloscope is a little bit low resolution, it's hard to see what's going on. I bet that helps if I reduce the pitch. Well, slightly. Alright, let's feed that envelope into here. Current envelope is a little slow. I want to fix this too. Let's try to make a good little plucking sound. I'm liking it. Sounds good. You see how much you get by just this module with a bit more functionality and sort of a little bit more advanced waves. It's actually all it takes to empower all this to sound like a lot more than it did before. And this is making me very positive about what's next. Okay, so what we also want to do is we want to let's bring some FM into play, because this has also got an FM input. Obviously this is not the layout we're going to go with, but this is sort of the testing layout. So okay, so we're going to need to split it again. So let's bring value. There we go. I'm being a little bit messy. I hope you can deal with it. Usually I like the racks to be tidier, but right now I just want to do something quick. Alright, so now the value should be also modifying this oscillator here. Let's feed that to the FM input. Ooh. Oh yeah. We're like on our way to making trance or something. Now we need shit tons of reverb and filters. And it'll be great. Cool. And the waves in here are replaceable. We just transfer those over from Unity. So. And hopefully it shouldn't have too much aliasing in the high frequencies. I'm gonna try that now. Hey, I think it sounds pretty clean. Yeah, a little bit in the top, but I don't think it's very bad. Oh yeah. And these almost have to be like zeroed out to do anything. Cool, I like it. I want to add a kick to it. I just have to. I have to. It's the last thing I'm going to do today. I just need to enjoy having made this work. You know, celebrate. A celebratory kick is what we need now. So let's bring in one more then. One more of them sequencers. And we're gonna need to split our clock. Sure, that's fine by me. And where's the oscillator? We're gonna have to. We're gonna need an amplifier for it. I'm gonna have to move my menu. over here, and the oscillator is going to go in the amplifier. We're going to need some envelope generators, or one. We need one just. I guess we can put that here, and we're going to feed the trigger to the envelope. Turn down, attack the key. Stay in release. That's what we're gonna get. Ooh, it's gonna be good. So, something's happening here. I'm gonna, before I'm feeding this in, I'm gonna add another splitter. Because I also want to modify the amplification of the kick I'm making. Let's try and feed this already, see what it sounds like. Hey, something's happening here. Oh, it's kind of offset. Still offset. Okay, I'm gonna use the chaos passy trick that we can do when we have very limited resources, very limited modules available. And what we're gonna do is we are going to feed the kick through a note quantizer, which is gonna screw it up in a cool way. We use the kick for anything over here. Oh, cool. We're making a really short kick. I like it. What else can I do? Anyway, the whole mixing issue around this as well. Very different volumes, aren't they? Ah, cool. Yes, I love it. I love it. And is Unity gonna crash? No! Whew. That made me very happy. And what a good note to end on. I think before I go, I'm just gonna read you guys. I see you guys wrote some stuff here. Let's see. Sounds like my monotron. Ooh, that's nice. I think we need to be able to see the value that the knob is at. Yeah, I was thinking about, so what do you think about this idea of tooltips? I was thinking that, like, once you select something and you start turning it, maybe it's not there all the time, but maybe it'll sort of show up the value, the number, 0 to 1 or 300 hertz or whatever, so you can sort of figure out what you're doing. Because to me, I sort of know what the different buttons do and what they map to, but yeah, it's not clear, I think, if you're just trying it out for the first time. I don't think it's clear how the different buttons map to whatever they're doing. So you guys, that is a great idea. Okay, sure. Oh, it's just the color of the emoji. Well, hats off to you, because that's a great idea. Let me just note it now. I'm gonna open up Trello and doing a wavetable oscillator. Well, we're still doing it. I was gonna finish it since I'm so happy that this worked out. I'm so happy about it. But this idea here, it's good. So we're gonna do component tooltips, and what we want to do is we want to do something like when a component is used, selected, pressed, etc. Show the value of the component. For example, 300 Hertz on an os, or -6 dB for a gain. Does that make sense to you guys? Okay, just reading up here. 4 on the floor, yes. All the 4s on the floors. That's what we want. Okay. Is there a way to snap the modules like a standard case? Not yet. I like to just say not yet, Neptune. But I agree. I think it is a good idea. So I think we should consider doing something like that. Sound is based on VR space. Yes, Thon, and welcome to the chat, by the way. The sound is panned. It's spatialized, depending on where you put your speakers. There's also a standard like stereo output, so you can use that if you prefer. You can simply create the stereo output module, and that'll sort of just blast the sound directly to left and right. Monotron, that's cool. It's tiny, isn't it? Didn't realize it was that tiny. Neptune, you've been blessed with a cowboy. That is good. That is good. I don't have any synths anymore. I used to have loads and loads of synths. Maybe that's why I started this project, because I miss synths. That might be the issue. I just have virtual synths now. But hopefully VR can help with that, make synths feel a little more real. So anyway, guys, it was awesome to hang out with you again. I hope you liked the stream. And if you have some feedback, ideas for me, leave them on the Discord. I do read it, as you know, and I do appreciate it. Trying to make this a fun, interactive experience. Yeah, let me know what you think, guys, and have a good one until next time. And OBS and